So, we have verified the answer. Now, what you can see here is minus 1 comma 2 is a point which is perpendicular to the which is lying on a line which is perpendicular to the given line. An interesting question can be asked that what is the distance of this point from the given line? Let us try to answer that question in the next slide. So, the question is, given any point, I have another line, the point is not collinear to the line, then what is the distance of that point from a line? So, let us try to take that as our goal. To be precise, we are interested in finding the distance of the point P which has coordinates x1, y1 of this point from the line L which has equation Ax plus By plus C is equal to 0. This is a general form of equation. Now, how will we proceed? So, if I want to understand the location of P, I need to do some analysis because Ax plus By plus C equal to 0 is a completely geometric object. So, I need to understand this line in terms of its geometric concepts. So, what are the geometric concepts associated with this line? They are slope, x-intercept, y-intercept or points on this particular line. So, let us identify those things first. So, if we assume that A and B both are not equal to 0, then I can rewrite this equation in the form of intercept form, that is x by A plus y by B equal to 1. So, in that case my small a is actually minus c by A, that is x intercept, and my small b will be minus c by B which is y intercept. So, I have identified this line as I have identified the 2 points, and these 2 points uniquely determine the line. So, I know how the line is located. Let us try to visualize this line in terms of the graph of a function. So, as you can see, I have mentioned that x intercept is minus c by A. So, it is mentioned as a point Q which is minus c by A comma 0, y intercept is minus c by B which is identified here. So, 0 minus c by B. The point P is located here. It may be located anywhere, but right now the point P is located here. It has coordinates x1, y1. So, now I want to identify a distance of this point from this line, the line joining the points Q and R. So, what is the distance? It should be the shortest distance from the line. So, the shortest distance in this case, if you move along this line, the shortest distance in this case is a point where the line is actually perpendicular, the point is actually perpendicular to the line. Okay. So, what I want to say is the shortest distance is the one which is the perpendicular distance. So, the entire question reduces to how to find this perpendicular distance PM. So, let us try to see what are the geometric objects associated with this. So, you can see from the dotted lines the geometric object that I can associate with this particular distance is a triangle PQR. Now, if I want to find the distance PM, I can take help of this triangle PQR, so that I will be able to find the distance PM. So, how will I do that? First, you see if I want to compute the area of triangle PQR, what do I need to know? I need to know the base and the height, and the area of a triangle is half base into height. So, half base into height means half times QR into PM. I do not know what is PM, correct, but we have already seen in this course how to find area of a triangle where its coordinates are given. So, I know even though I do not know what is PM, I know how to compute the area of a triangle. The next question is, do I know how to compute the length QR? Yes, of course, because this is x intercept, this is y intercept, and these are the lines which are the distances on x and y axis, and all of them form a right angle triangle. So, by Pythagorean theorem I will be able to find the length of QR. So, I can reformulate the question as PM is equal to 2 times area of triangle PQR upon QR. So, now I know how to compute the length PM if I know how to compute area of triangle and how to compute the length of line segment QR, both of which I know, right. So, let us go ahead and try to compute area of triangle PQR. So, here is our formula for area of triangle PQR, which has coordinates x1 y1, x2 y2 and x3 y3. So, let us start with x1 y1. The x1 y1 is the first coordinate. Remember, you will always take this in anti-clockwise direction. So, I will start with this this coordinate, then I will go to R and then I will go to Q. So, this is x1 y1, this is x2 y2 and this is x3 y3 according to the notation that is given in the formula. So, you will see x1 times y1 is minus c by b and y3 is x1 is the first coordinate. You look at this term x1 into y2 minus y3. So, x1 is first coordinate, it will remain x1 because P has coordinate x1 y1, y2 is minus c by b, y3 is 0. So, you will get x1 into minus c by b minus 0, then the next term, that is x2, x2 here is 0. So, this entire thing vanishes. Then you go to x3. What is x3? x3 is minus c by a into y1, which is y1 as it is, minus c by b. So, y1 plus c by b. This is how I got the formula. So, if you look at this formula closely, you can actually take c common from all within the mod sign. So, you can take mod c by b. Denominator has b and AB, terms containing b and AB. So, you can, if you want to take those terms out, you multiply throughout by AB. So, you will or you find the LCM is AB and you take AB out. So, you will get half times mod c by mod b, a x1 plus b y1 plus c. Remember, this is the term corresponding to general form of the equation. Now, we have seen how to compute area of triangle PQR. Next, we will see how to compute the length QR. But length QR is actually very easy because I have a point Q which has only x coordinate and I have a point R which has only y coordinate. So, it is as if computing the distance of length QR is square root of c square by a square plus c square by b square. These are the two sides of the triangle and this QR is the hypotenuse of that triangle, right angle triangle. So, you can simplify this to amend to this form. So, you can take out c common. So, you will get mod c, you take a and b common. So, you will get mod ab and then you will get square root of a square plus b square, which is in the numerator. And now, if you look at this form PM, which is the length of the line segment PM, is 2 times area of triangle PQR upon QR. So, now it is just a matter of feeding the values. This half will get cancelled with this 2 and area of triangle PQR is this and QR is this. Therefore, these constants also will vanish because they are same and you will get the formula to be equal to modulus of a x1 plus b y1 plus c upon square root of a square plus b square. This is how you will calculate a perpendicular distance of a point from a line. Now, this idea can be helpful in finding one more thing, that is a distance of a distance between two parallel lines. So, the question can be asked is, I have two parallel lines, what is the distance between two parallel lines? So, let us take the setup. Because the lines are parallel, L1 and L2, they have common slope or the same slope. So, their slope is m. Then you can use the slope point form, which is y is equal to mx plus c1. Now, I want to use the previous concept that I have introduced, distance of a point from a line. So, I will first identify this with x intercept. So, what will be the x intercept in this case? If you identify this line, it is very easy to see. Go back to the general form and figure out that x intercept is minus c1 by m, because b is equal to 1 here, a is equal to minus m, and capital C is equal to small c1 minus small c1. So, the intercept is this minus c1 by m. Let us take another line, that is L2, it has same slope. Identify it with our standard form, a is minus m, b is 1, capital C is small c minus small c2. Okay. So, now given x intercept, what are the coordinates of this x intercept? Minus c1 by m and 0. So, now the problem reduces to finding the distance of this point from this line. Okay. So, by using the distance of a point from a line formula, where the point is minus c1 by m comma 0, you just need to substitute this point x1 y1 into this into the formula for the distance of a line, which is given by, so I am just a x1 plus b y1 plus c in the modulus upon square root of a square plus b square. So, my point x1 is minus c1 by m substituted here, y1 is 0 substituted here, you will get the formula to be equal to c1 minus c2 upon square root of a square plus b square. So, in this case a square plus b square, b was 1, a is m minus m, so it is 1 plus m square. Now, you can actually identify this formula in the general equation form also. So, in the general form, instead of b equal to 1, we have slope which is equal to minus a by b, and c1 is equal to minus c1 by b, and c2 is equal to minus c2 by b. Right. So, this I am matching with both equations in general form. These are slope point forms, but now if you match these equations with a general form, you will get this description of the line, where you have ax plus by plus c1 as one line is equal to 0 as one equation of line, ax plus by plus c2 equal to 0 as equation of the second line. So, in that case, this is the form, and therefore, now you just substitute with these identifications, substitute these values into this expression. So, this m will be replaced by minus a by b. So, you will get square root of a square plus b square here, and some mod a b will come out common, and therefore, finally, that will cancel off with this b, and you will get the expression of the form mod c1 minus c2, which are the c1 and c2 belong to general form of equation upon square root of a square plus b square. So, this gives us a clear cut understanding of the interconnection between the slope point form and general form of equation, and we have figured out what is the distance between two parallel lines using distance of a point from a line formula. Okay. So, now we will solve some examples to concretize the concepts. So, here are the examples in line. So, you have been asked to find a distance of a point 3 comma minus 5 from the line 3x minus 4y minus 26 is equal to 0. So, in this case, you just need to apply the formula. What is the formula? ax1 plus by1 plus c in the modulus upon square root of a square plus b square. So, what is A, B, C here is the key question. x1, y1 is known to be 3 comma minus 5. So, A is 3, B is minus 4, C is minus 26. Then you just need to apply that formula, that is A x1 plus B y1, which is minus 5, C is minus 26 plus C minus 26, and upon square root of 3 square plus minus 4 square, which will give me the denominator will be square root of 25, it will give me 5, the numerator will be 3. In a similar manner, you can ask a question, what is the distance between two parallel lines, x plus 3x minus 4y plus 7 is equal to 0, 3x minus 4y plus 5 is equal to 0. So, it will be mod C1. So, what is a formula that we have derived? It is mod C1 minus C2 upon square root of a square plus b square. It is very straightforward. So, what is C1 here? C1, the first line, the constant term is 7, the second line, the constant term is 5. So, it will be modulus of 7 minus 5 upon 3 square plus minus 4 square. So, you will get the answer to be 2 by 5. Okay, done.